So write down the heading, family 3, in which number of link will be still 4, number of lower pair will be still 4, but 2 will be revolutory, 2 will be prismatic. Okay, 2 revolutory, 2 prismatic. Degree of freedom will be 1. Who will be the grandfather here? Grandfather का नाम क्या है यहाँ? Grandfather is double slider crank mechanism. Double slider crank mechanism. Okay, चलिए, let's take a 2-3 minute break, then we will start, है ना? Because lights are there and I feel so much heat here from outside, है ना? All lights are focused on me. चलिए, so just 2-3 minute break, then we will start it. मिलते हैं 3 मिनट ब्रेक के बाद. वेलकम बैक. कोई बाहर तो नहीं रह गया क्लास के? ओके, so double slider crank mechanism. Okay, so here first inversion we will write elliptical trammel. Elliptical trammel. Okay, so what are the figure? Look here. This is a fixed frame. In this fixed frame, there are groove is cutted. Okay, so these are like two your cylinders. Okay, one is vertical groove and one is horizontal groove, or in x direction, y direction. They will behave like cylinders. Okay, so this is fixed. This whole frame is fixed. They are like cylinders, grooves. Okay, now here two slider will be there, like two pistons. Okay, so let's say this is first piston and this is the second piston. Two sliders are there and these sliders will be attached by a bar like this. Okay, sliders are attached by a bar like this. Here this is, let's say, x axis, this is, let's say, y axis, and this is the origin O. Okay, now first of all, for the first this what to say inversion, we will fix the link 1. Okay, fix link 1. Fix link 1. So this fixed link will be considered as 1. Okay, second will be this slider, third will be this rod, and fourth will be this slider, let's say. Clear? This point I am considering A, this point I am considering B, like this. Okay, now these will move like what? This cylinder this piston will move in horizontal cylinder like this, and this piston will move in vertical cylinder or groove like this. Okay, simultaneously both will be moving like this. Okay, so here let us do the analysis of the motion and how they are moving and what will be the relationship, and in this generally they ask what type of question. Okay, now let us assume this is any general point C on the bar AB. So general coordinate of C will be x comma y. Okay, so this distance will be your y distance and this distance will be your x distance like this from the origin. Yes or no? Like this. So this is y, or you can say this will be y from here to here. This is the y distance. Okay. This is the x distance. And right now let's say it is making some angle theta with the x-axis like this. Theta with the x-axis. Okay. Now for the analysis, write down here. First thing, consider the triangle ADC. Triangle ADC. What is the D point? This will be your D point. ADC. So in triangle ADC, what you will see? Sine theta. So here sine theta will be equal to, or you can write AC sine theta will be equal to y. Yes or no? This will be. And next, take the triangle BCE. This is, let's say, point E. Triangle BCE. Okay. So in this, there you have taken the sine theta. Here you can see this angle will be also theta. So BC cos theta will be equal to x. X. Yes or no? So from this you can calculate the sine theta. Y upon AC. This will be cos theta x upon BC. So add both the equations after squaring. So इसका first का square plus second का square you can do. Yes or no? So add both the equations after 1 square plus 2 square. What you will get? Sin square theta plus cos square theta equals to y over AC square plus x over BC square like this. Yes or no? So this will become 1. So what will be this equation now? BC square plus y square AC square equal to 1. What is this equation? This equation will become the equation of ellipse. Yes or no? So this will be your equation of ellipse, a standard equation of ellipse. Equation of ellipse. Yes or no? So this point C, when the slider will be moving like this and like this, the bar will be doing T plus R motion. Sometime it will be like this, sometime it will be like this. So bar AB will be doing T plus R motion, and this point C will move on a ellipse like this. Point C will move on a ellipse like this. Yes or no? Now in this special condition, if C point is midpoint of AB. C point is midpoint of AB. Then AC equals to BC. Both will be equal. Both will be equal. Yes or no? And let's say this is L by 2. उसका length L है. Let's say AB is L, then it will be L by 2. Yes or no? So from equation 3, what will be the value? X square plus y square equals to AC square BC square, both will be equal and they can be taken as L by 2. So it will be L by 2 ka whole square. Yes or no? Now if I am considering L by 2 as R, L by 2 as R, okay, so here L by 2 I am considering R, let. So this will become equation of what? X square y square equal to R square. This will become your equation of circle. Yes or no? So simply then this point will move on a circle. So it will be your standard equation of circle. Standard equation of circle. Yes or no? Means any general point on the bar AB except the midpoint will move on ellipse. Only the midpoint of this bar will move on a circle. Got the point or not? Midpoint of this bar will move on a circle. बात समझ आई? तो यहां पर आप लिख देंगे बाकायदा नोट the midpoint of bar AB will move on a circle. Okay, all other points will move on elliptical path. All other will move on elliptical path. तो ऐसे in older time there is simple things are available to make the circle, perfect circle, but how to make a perfect ellipse? This is now software, it can make the perfect ellipse like this, but previously there was no software how to make a perfect ellipse. To make the perfect circle there are many devices. You just take a thread and hold one end and rotate like this, a circle will be formed, or by rod or by simple your compass, all these things. But how to draw a perfect ellipse? For that this device was used. Okay, so if you will take a elliptical Dremel like this, you take two slider and all these things and attach a pencil here and attach a pencil here like this. Okay, and put this device on a table and move these two slider like this. So you have to do input only translation for the sliders, but that pencil will move on the elliptical path. So on the table or drawing sheet it will draw a perfect ellipse. That's why its name is what? Elliptical Dremel. Okay, तो यहाँ पे लिख दो what is its use to draw perfect ellipse. इससे आप सर्कल भी ड्रॉ कर सकते हैं, बट सर्कल you can draw by other methods also. So this is the device to draw a perfect ellipse. Everyone clear with this? जय हिंद लिख दो. Everyone clear up to this? Write down Jai Hind. Very good. तो बस आपको क्या करना है, यू हैव टू अटैच ए पेंसिल विद द बार ए बी एट एनी अदर पॉइंट other than the midpoint. A perfect ellipse will be drawn on the drawing sheet. What a beautiful thing. By free hand you cannot draw perfect ellipse. Next, inversion of this mechanism. Second लिखो, Scotch yoke mechanism. Second, Scotch yoke. What is the spelling? SKOTCH. I generally forget these spellings. Mechanism. No issue. Concept is important. So here we will fix the link to. Fix link to. And link 2 was our slider. Yes or no? In our main this link 2 is slider. Any slider you can take as link 2. Both will have same effect. So any one slider will be fixed here. Clear? Any one slider will be fixed here. So you will fix a slider. वाह, बन तो गया. हाँ. Inside this there is a piston. And this is the x-axis, y-axis, like this. And here look, we are fixing one cylinder. Okay, so let's say this is open cavity like this. Okay, and inside this one bar can be there. One bar can be there. Okay, so slider we are fixing, and slider and piston can be interchange. Already we know. So either this can be taken as slider if it is inside. Okay, if it is inside. So if I draw like this, then this body will become your slider. This body. But if I take a fixed link inside here like this, then this will become like a cylinder. Got the point or not? So I can modify and I can simply draw like this, because cylinder and piston can be exchanged. We already know in many mechanism we have done this modification. So now this is slider, this is cylinder, but here this is slider, this is cylinder. So this cylinder is fixed, and this cylinder will have same like this. Whole body is one, so one cylinder is actually fixed. Okay, so next inversion will be found. So let's say according to numbering, this is our link number 1, this is link number 2. This time we are fixing the link 2, and this is our link number 3, let's say, and this is link number 4. Clear? And this is again link number 2. Clear? Now here this is A, let's say, and this is B, and this is rotating like this with constant omega like this. Link 3 is rotating. So when link 3 will rotate continuously like this, so this piston 4 will go up and down in this frame, है ना, up and down in this frame, and this frame will go right and left in the cylinder 2. So this will be the motion. Clear हुआ यहाँ तक? So when it will be having pure rotation, this will be having to and fro motion. This link will perform SHM. This link will perform SHM. So here I am writing this link will perform actually SHM. How? That we are going to do analysis of it. Okay. So let's start this. Let's say this is the radius R, or you can say length of AB link, length of the AB link. Similar radius circle we will draw here like this. Similar radius circle we will draw here like this. Okay. And here draw this radius at any general point like this. Initially this link AB will be here. Initial position of this will be here. When it will rotate by some angle, let's say theta, this point B will reach here. When this point will reach here, the slider will move left side by this much amount. When it will rotate by this angle theta, this slider will move left. Yes or no? So that general distance I will consider x. That general distance I will consider x. When it will rotate by theta, then this will come leftward by general distance x. Okay. So what will be the value of it? Let's say this is the center A, let's say, and this is the B, this is radius R, and you are moving with constant omega like this. Okay. So this was x, total will be R. So this will be how much? R minus, or you can say this will be R cos theta actually, sorry. X will equal to R minus R cos theta. Yes or no? Because this total will be the radius R. Everyone clear with this? So write down here in next line that for the angular motion of link AB by angle theta, the slider will move by distance x as shown. Okay. So here the distance x will become simply R minus R cos theta, or you can write R common 1 minus cos theta. So when the displacement is here, distance and displacement will be same. So when the displacement is function of sin theta cos theta, always it will be equation of SHM, or you can say SHM equation will be there. Okay. So here x you have found, x you have found. Now because the link is rotating with constant omega, so what will be the value of omega? It will be angle upon time simply. So what you can write at the place of theta, you can write omega into t. Yes or no? Very simple. So your x can be written as r into 1 minus cos omega t. So this will be also the equation of displacement. Now velocity v will be equal to simply dx by dt. So here it will be r, it will be 0 minus cos omega t will become minus sin omega t into omega t will become omega. Yes or no? So the velocity of slider will become r omega sin omega t, like this. Now acceleration you can find. Acceleration at any instant will be what? Acceleration will be like r omega will be like this only, and sin omega t will be cos omega t and further into omega. So acceleration will become r omega square into cos omega t, like this. So this is equation of the velocity and this is equation of the acceleration. So both are in terms of sine and cos. So this is certainly SHM motion, SHM motion. Clear? तो इसको लिख दो. So when velocity, acceleration, displacement, if these are in terms of sine and cos theta, these are the equation of SHM actually. These are equation of SHM actually. Okay, very good.